So this is a solution to this super nice quintic equation. The reason that this is super nice is because the inside here plus the inside here happens to be the inside here. Well, to be honest, it's not happens to be, it's set out to be so. And I will also tell you though, if you make the inside here equal 0, you get x equal to 3. And then do the same thing here, the next one you get 7. And then do the same thing here, you will see x is equal to 5. In fact, these are the 3 real solutions that will satisfy this quintic equation. However, since this is quintic, we will have a total of 5 solutions. We actually have 2 more, but they are complex. And in order to get that, I will show you guys the following approach. Check this out. Firstly, because the inside here plus the inside here is equal to this, and I will just put a note real quick. 2x minus 10, we can factor it, and that's 2 times x minus 5. And this right here happens to be the middle of x minus 3 and x minus 7, which is super nice. So we'll do a substitution first. I'm going to let t equal this. And then right here we have x minus 3. That will be t plus 2. And then to the 5th power. Okay, and then continue. This one will be t minus 2 to the 5th power. And this right here is 2 times t. And then to the 5th power. So whenever you can see any nice connections between the inputs, maybe sometimes if you do a substitution first, the algebra will be much easier. In this case, like that. Because if you want to expand the original, I think that would be pretty bad. Now, this right here is much better if we expand it because you can see the nice cancellation happening later on. Even though it's a 5th power, not so bad. We use the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. These are the coefficients that we are going to use for the expansion. And here we go. For the first one, we start with 1 and then t to the 5th plus the next coefficient here is 5, and then the power of t goes down by 1, so it's t to the 4th. But the power of 2 goes up by 1, so it's times 2 to the 1st. And then continue. Plus 10 t cubed, 2 square plus 10 t square, 2 cubed plus 5 t to the 1st, 2 to the 4th, and lastly 2 to the 5th, not 25, 2 to the 5th. So that's for the first one. And then we are going to combine it with the second part. I will write this down in blue. When we have a subtraction, the sign will alternate. We'll start with the first one as still positive t to the 5th. But the next one, well, depends on how you want to do it. You could put a negative here. We can say add and then negative 2 square, up to you. I think we'll just do that. I think it's easier that way. So 5t4 times negative 2 to the 1st, and then yeah, continue. This is more consistent in my opinion. And then just 10t square, negative 2. And then 5t times negative 2 to the 4th, and then plus negative 2 to the... Oh, why did I write 25 again? Yeah. And then lastly, that's equal to... And this is equal to 2 to the 5th, which is 32. And then we have t to the 5th. Now here's the deal. This and that will cancel to 0. And there will be just twice, right? Because that will be positive. Likewise, this and that will be out. And then this and that will be gone as well. Now we can just add them up. So we are looking at 2 times t to the 5th, and then the middle part, let me just write this. That's 4 times 10. And 2 of them is in the front, so it's 40 t cubed. And then we have 16 times 5 is 80. Yes, t to the 1st power, and then yeah, and that's equal to 32 t to the 5th. Cool, and then we can reduce the 2 on both sides, so cancel this right here, and that will be 16. Oh, this is so nice. Look at that. Why? Because Oh, no, not really. Because right here we still have t to the 5th plus 40t cubed plus 80t. I forgot this is the 16t to the 5th. I was about to cancel the t to the 5th. No. Okay, I'll bring these three things to the other side. So we get 15t to the 5th, right? And then minus 40t cubed minus 80t equals 0. And then we can factor out a 5 and also the t. And then we get 3t fourths minus 8t squared and then minus 16. That's equal to 0. This right here also is quintic, but it's actually quadratic in terms of t squared. We can factor it pretty nicely. We get 3t squared and t squared, and to get negative 16, let's do 8 and 2. 8. 2, 8, no. 4 and 4, 4, 12, 4 and 4. So I'll do 4 here and 4 here. That will be I can't think. I need this to be negative. Yeah, so this right here becomes negative 12t squared, and that right here becomes 4t squared. So we do get a negative 8t squared. So we get 5t times 3t squared plus 4 times t squared minus 4. And all that is equal to 0. From here, you can see that t has to be equal to 0. And from here, t has to be, subtract 4 from both sides, you get negative 4. Divide 3 both sides, and then square root both sides. And then don't forget the plus or minus. And then right here, t has to be 4, and then you do the square root, so it's going to be plus or minus 2. Okay, t equals 0, that means x minus 5 equals 0. So first answer, x is equal to 5. Done. Next one. Okay, x minus 5 equals plus or minus. I'm just going to bring the negative out and then put that as an I. And then we have square root of 4, which is 2. So I'll put the 2i like this. And then I'm just going to keep the square root of 3 on the bottom. And then bring the 5 to the other side. So 5 plus or minus. Okay, fine, I will rationalize the denominator here. So 2i square root of 3 over 3. So 2 more answers here. These are the 2 answers that we were missing it from earlier. And then finally, x minus 5 equals plus or minus 2. 5 plus 2 is 7. And then 5 minus 2 is 3. That's it.